Identify chirality centers and enantiomers. Okay, now let us look at how to identify the enantiomers. Sorry, identify the chirality center. Okay, let's say you are given a compound, the condensed formula, then you draw the expanded structure or expanded plus condensed. Okay, then the first one that you can eliminate is those that are not sp3 hybridized. Okay, for example, this carbon is sp2. This carbon and this carbon is also not sp3 hybridized. They are sp2 hybridized. So we only will consider two carbon here. That is this carbon and also this carbon. Okay, actually we can also consider this carbon, but clearly it has three same groups. So we are not going to look at this one as well. Okay, so when we look at this carbon, okay, let's use another color. Okay, when we look at the blue color carbon, okay, you can group them into four different groups. 1, 2, 3, 4. Okay, it has four different groups. So this carbon is the chirality center. So on the condensed formula, you can put asterisks there. Okay, because the question is label the chirality center. Okay, now we go for another one. Okay, that is this carbon. Okay, if we have this carbon, we can see that we have two same group. When there are two same group, means there is no chirality center. Okay, now we go to draw a pair of enantiomers using 3D formula. Okay, now what are the common mistakes from students? Okay, students have no problem with identifying the chirality center. Okay, what I would usually advise students to do is, okay, from this four group, for example, 1, 2, 3, 4, the biggest group or the largest group or most difficult to draw will be group number 3. If it's most difficult to draw, I will put on top. Okay, why? Because if I put on top, I don't have to draw the mirror image of each other. Okay, what do I mean by that? Okay, for example, if you look at OH, okay, H is on the left, this hydrogen is on the left, then another hydrogen has to be on the right because they are mirror image. Okay, but if you put on top, okay, you don't have to do the mirror image when you are drawing the enantiomers. Okay, so this part, so the most difficult I will put on top. Okay, now what are the common mistakes that students make? Okay, first of all, you can see here I have highlighted CH3. If we look at the structure, it is attached to CH2, not CH3. Thus, it is incorrect. Okay, another one. This carbon is attached to oxygen. Okay, so when we draw, it must be attached to oxygen. Okay, however, some students will write connect to attached to hydrogen. So it is incorrect. Okay, another one is bromine. Okay, RB is not bromine. Okay, bromine is BR. Although we said that it must be mirror image, okay, but remember this is a bromine atom. So if we really use a mirror to look at it, it is still bromine. It is not the symbol of RB. Okay, so when you answer this kind of question, just remember if it asks determine if it is optically active or not, you must answer yes. Okay, then draw a pair of enantiomers. Make sure you label the word enantiomers and draw the mirror image dotted line. Okay, so that's all for this part.